Supplemental math videos from Circle Christian School.
Adding and subtracting radicals. Add and subtract your like radicals. In real-life applications, you often have to simplify algebraic expressions involving radicals. For instance, simplifying the radicals in the golden section used by the Greeks in architecture makes for a more exact value. When we add and subtract, it always has to have a like radical. That is, the guy underneath the radical always has to have the same value. So for instance here we have a radical 7, a radical 7, and a radical 7. So therefore we can add them together. All we're doing is adding the coefficients. We have a 1 here, a positive 5 here, and a negative 2. And those are what we're going to add together. 1 plus 5, take away 2, is a positive 4, and then the square root 7. We can only add coefficients to coefficients and like radicals together. In the next problem too, you'll notice that we have radical 6, and then we have a radical 3. And although 3 and 6 have some neat things that go together with each other, because they're not the same value, that is, the square root of 6 is somewhere around 2 point yada 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 yada, and the square root of 3 is 1 point yada yada yada, you notice that those two are not alike, just in their values by calculator. So we cannot add them together, only the ones that are totally alike, a square root of 6 with a square root of 6. And so what we're going to do is add together our coefficients. Just watch the sign. 6 take away 5 is 1, so we have a square root 6. And on the next one, with the 3's, now we're going to deal with the 3's, we have a negative 1 plus a 2 is a positive 1 and a square root of 3. On number 3, there's a couple of things that we have to be careful with. You have to take a look at the index. For instance, we have an index of 4 here and an index of 4 here. But on the last one, although it is a radical 5, it is actually a square root, not a fourth root. So the only ones we can add together are the ones that have fourth root 5's. So 3 take away the 8 is a negative 5, fourth root 5. And since there aren't any other square root 5's, he'll stand alone with a little addition sign in front of him. Because our radicals can have variables underneath them, the same rule applies. We can only add a square root x to a square root x. So we go through the problem here again and just find things that are alike. And generally, I like to deal with our rational numbers and put them at the front, and then our irrational numbers toward the back. So I'm going to add the 3 and the 4, which is going to give us a 7. And here we have a radical x and a radical x, remembering there's a 1 in front of there. So the 2 take away the 1 gives us a positive 1 and a square root x. Now you'll notice on the next one we have radicals that are just not alike in any shape or form, but we do have radicals that we can simplify. So that's what we're going to do first. We're going to simplify our radicals and see if we end up with like radicals so that we can add them together. So we're going to bring down the 2 because it says we have 2 of these radicals here. So there's my 2. And then we're going to start breaking up 72, which is 8 and 9. 2, 2, and 2. And then the 3 and the 3. And it's quite possible, but you remember that the square root of 72 is 6 square root 2. We can pull a 6 out and leaves a 2 underneath. Bring down the minus sign. 2 and 2 is 4. 4 and 2 is 6. 6 square root 2 is 6 square root 2. 2 and 2 is 4. 4 and 2 is 6. 6 square root 2 is 6 square root 2. 2 and 2 is 4. 4 and 2 is 6. 6 square root 2 is 6 square root 2. 2 and 2 is 4. 4 and 2 is 6. 6 square root 2 is 6 square root 2. 2 and 2 is 4. 4 and 2 is 6. 6 square root 2 is 6 square root 2. 2 and 2 is 4. 4 and 2 is 6. 6 square root 2 is 6 square root 2. 2 and 2 is 4. 4 and 2 is 6. 6 square root 2 is 6 square root 2. 2 and 2 is 4. 4 and 2 is 6. 6 square root 2 is 6 square root 2. 2 and 2 is Bring down the 2. It's a coefficient. And 32, you'll remember, is 5 2's. So a 2 comes out and a 2 comes out, which gives us a 4. Leaves us with the square root 2. And now we have those like radicals. So 2 times the 6 is 12, square root 2. And 2 times 4 is 8, square root 2. And 12 take away 8 leaves us with 4, square root 2. Last one, same game. We're just going to have to do some simplifying before we can go and move on. And so nothing in front of the square root 45x, which is going to give us a 5 and a 9. And 9 is a 3 and a 3. Little branches can go off to the side here. So a 3 is coming out. And square root 5 and the x stays underneath. Plus, we're going to bring down the 2. And we're going to simplify the 20, which is a 4 and a 5. And remembering that 4 is 2 and 2. So the 2's are coming out, so times a 2, square root 5, and the x stays inside. And now we've got those like radicals. So we end up with 3 square root 5 plus a 4. Oh, I'm sorry, I forgot the x. Square root 5x is going to equal 7. That's our coefficients here. And our radical 5x. Sometimes we have to do some simplifying on the inside before we can go play on the outside. Just a fact of life. After all, Mother does say, gotta clean your room up before you go outside. It's kind of one of those. So I'm going to clean my room up before I can go outside. So you'll notice that in the top radical, we can actually factor out a 9. And we get an x minus 1 as a leftover. Minus sign. And on the next radical, we can actually factor out an x squared, which is going to leave us with an x minus 1. I bet you're starting to see something familiar here. Splitting them up, that we can do in multiplication anyway. I have an x minus 1 minus square root x squared times the square root of x minus 1. That's going to leave us with a 3, square root x minus the 1, minus sign, have an x, square root x minus 1. And so you'll notice that we have like radicals here. Awesome, cool. But we have coefficients that aren't alike, but we still have to add them together. Okay, there's two trains of thought as to how to go and write this. I'm just going to show you my way and how I leave it, and then I'll show you the way that maybe possibly some books will have. So I'm just going to go 3 minus the x, because that's my little coefficients, and then I would go the x minus 1 under the radical. Some other books would go square root x minus 1, because that's what really got factored out here, and then leave it at 3 minus the x. So I'm just going to tell you, hey, whatever floats your boat, good for me. On the next one here, you'll notice that it's a cube root. So anytime you kind of get a wrong answer in the back of the book there, just always look to see if it wasn't a cube root over a square root type of thing. So here it's going to take 3 for anything to escape. And I'm just going to start shortening things down. Let's see, I have a 10, 11, no, okay. So I can divide by a 4. So that's what I'm going to do. Divide by a 4 is going to leave me with a 3 and a 2, 32. Oh, I see some nice numbers there. And you'll remember that 4 is 2 and 2. And that 32 is 5 2's. There we go. kind of tight there. Yes, it is 3 o'clock. You'll just never know if it's 3 o'clock in the afternoon or 3 o'clock in the morning. So I'm going to take a 2 out, take another set of 2's out, and that's going to leave 1 inside. Now I'm going to leave myself a little bit of space here before I draw my radical, because I've got some x, y things going on here. And so we have a 2 inside. So x to the 9th, 9 divided by the 3 with none left over gives us x to the 3rd power. And 10 divided by 3 with 1 left over gives us a y3 with a y left over. Okay, minus sign, just going to bring this guy down. So we have a 2, an x squared, and a y. Again, we got a cube root, so we got to do 16, which is 4 and 4. If you're really savvy, you know that it's got 4 2's to it. So we know a 2's coming out. So we have another 2. 2's going to stay in. And again, I'm going to leave myself a little bit of room here because I know there's things happening with some x and y's. So a 2's staying inside. We have an x to the 3rd power, so we know a x is coming out. Y to the 7th power, 7 divided by 3 goes evenly twice with 1 left over. Oh, I like it when I see same stuff. All right, let's do a little bit of simplifying. Remember, it's simplify, 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 simplify. And when you think you're done, simplify some more. So we have a 4 x to the power 3, y to the power 3, cube root. I lost my cube roots here. Happens all the time, so I'll just throw them in. So I know it's a cube root. 2y. And minus sign. We have a 2 and a 2, so we have another 4. We have an x squared and an x, so it's x to the 3rd power. And a y squared, so it's y to the 3rd power. Cube root 2y, and look at that. We have a 4 x cubed y cubed minus a 4 x cubed y cubed leaves us with a 0, and the 0 in front of any radical would just leave us with 0 anyway. And looky here, we did all that work just to get nothing. All right, guys, go have an awesome day.